All right, looks like you're live, so I'll activate you back over here. I'll be around for a little bit just to make sure that it gets up and running.
Okay.
Thanks, Karen.
Thank you. To keep up with all of that, again, on the website, at the bottom of the website, you will see the calendar is CEU list. We will try and keep this up to date as much as we can. If there's any issues with it, just let us know. But there is a calendar of events there that you can find that will list all the events for the year and which ones get CEU credit, because the other events disappear after we finish with them. AIA they go away, so we can keep up with the ones that are really coming up for us. I also want to thank Micah Moffitt, because she has done a tremendous job of fielding everything and coming in, stepping in as our new executive director. She's only supposed to work 1 day a week, but she's working pretty much full time, I think. And she is really behind the scenes. She's straightening out a lot of our different issues, everything from how we relate to national, to our accounting, to our taxes, to everything in between, even figuring out how members are transferring in and things like that. So I want to just give we're hoping that, correct me if I'm wrong, but I'm thinking that the schedule is that we will be putting stuff out late spring, early summer. The jury should be sometime in September, right?
I think we're thinking about the event being
The event being sometime in September. Okay, so think late spring, early summer for getting submissions in. Be watching for that. It's not on the website yet, but just be thinking of those projects that you want to enter into that. Also, on the February 27th at the Alamo, there will be a showing of a movie called The Definitive Story of the Movie Palace. And we are working with Alex Wiley to hopefully be a moderator for that, to talk at that event about cinema architecture. And so it should be an interesting piece that we will have that posted soon. And it is in the newsletter. So just be aware it's at the Alamo on February 27th. So it should be an interesting event about cinematic architecture. We also have the We Create competition, which is going right now. And then a couple other things, the Vernacular Creative event that's in Branson, I believe. We also have YAF going on, a lot of YAF events that the Career Social after the Career Fair. The Career Fair is coming up March 6th, I believe is when it is. And then our next component meeting next month. We also have scholarships. We're moving our scholarships forward, so they are due on the 17th. That way we can celebrate them this spring at the HSA Awards, and then also in the fall at the Salute to Construction. We also have AIA Grassroots Advocacy Day coming up in late March. Jennifer, do you want to say something? Jennifer is our AIA Missouri president, so we're happy to have her serving as president here.
We would love to have you there March 31st all day. We're not working, so how you can be there. Last year it felt like we were fighting legislation, when licensure over and over again, and this year was much more benign. But I think it's good just to get our face out there, let it we are. So please put Jeff City on March 31st.
We've had a couple of lectures that have moved around a little bit for HSA. The Jules Dingle one will be later in March. Then we also have some other kinds of issues. In the newsletter, you might have seen that there was a call to action. This had to do with, there is a, Russ, help me with this. Is it an
executive order.
The executive order asking that, or encouraging that all federal buildings and courthouses be done in classical style.
Classical style.
I don't even know what to say about that, but so there is a link that we sent out in that website. You can also, I think you can find it on AIA. The important thing is that we need to get word back to our representatives and AIA, I guess.
Yeah, so no matter what side you're on, hopefully as designers you see that this is an issue for architecture. And as of yesterday afternoon, only 10% of licensed architects in the nation have clicked on our link. So they were just asking that you click the link and say that you're opposed to this executive order.
Unless we do actually want to hold an application. So yeah, so it would be greatly appreciated if you would, at some point, go back, click on that link, and let them know that we don't necessarily all want to be designing in the classical style. Another thing, this is Founders Day for AIA Springfield. 55 years ago today was when Richard Stahl, Jennifer's grandfather, started the chapter here. And so we are asking that if you have any history of your firm, If you would send us pictures of early days of today, let us know when you founded your firm, and we will put that on Facebook. Get that just kind of on social media. We think it's great that we've been around for over 50 years. It's a nice little milestone for us. So we'll celebrate that this month. So I do want to see pictures of when everybody started their firm and what you looked like back then and everything like that. It's just yesterday, right? And then one other shout out to Jake Wells. They they were listed as one of the emerging voices by the Architectural League of New York. It's a great honor, and so it's wonderful to have firms of this caliber in our component. We're grateful for all of the engagement that our firms have. So it's a nice little honor for them. Any other announcements? Any other things that I need to add? All right, with that, I will introduce Brad Palmer. I am really glad that Brad is here to talk with us today about Springfield energy codes. Brad, besides being an engineer in town, he's very valuable to AIA Springfield. He has been on our board for as long as I have been there, and
yeah, it's been 6 years or so, something
yeah.
like that. Jason was the one that called me and invited me. So.
And he's been a great asset for us on the board. He's also one of the title sponsors for us, so Enterprise is a great source for us just as a support. We're very glad to have him as a title sponsor, and we're really glad that you're here to talk with us about Springfield energy codes. So I will turn it over to Brad.
Thanks for having me. All right, Brian, what do I need to do here? Maybe I can figure this out. Oh, I clicked that thing there. Are we streaming? We are. All right, we're streaming internationally here, worldwide. I might walk around a little bit. I hope that's okay. But thanks for having me. Yeah, like Karen said, my name's Brad Palmer. I'm with Interpret's Building Solutions. We're MEP engineers here in town. Tanner, my partner there, Tanner and I founded the company in 2013. We're licensed in over 30 states and adding more all the time. And I just checked, and in the time we've been in business, we've designed over 700 projects that are either under construction or built. So. I am a past president of ASHRAE, which is used to be the American Society of Heating, Refrigeration, Air Conditioning Engineers, and currently serve as the government advocacy chair for our local chapter here. And kind of in that capacity, got into a conversation with the city of Springfield as they were looking at updating into the 2018 energy codes, which recently took effect, building codes, which recently took effect, and talked specifically just about what was in the energy code, kind of the implications it would have on design and construction here, and just try to be a resource. Tanner was in those conversations too. Lots of stakeholders were involved in all those conversations, and so just trying to be kind of a resource to help understand implications of what might be associated with the code adoption. So anyway, I'm happy to get the chance to come and talk with you a little bit today about what we can expect. So let's look at the learning objectives. We're going to understand the requirements of the 2012 Energy Code and the exceptions that pertain to Springfield. 2012 is the version we adopted. We'll look at that in a second. Kind of look at design constraints and ways that the Energy Code allows us to maybe make some moves that will open up some alternative possibilities. I'm an MEP engineer, so I'm going to highlight areas where there may be a coordination flag to throw up in your mind where you want to get with your MEP engineer and make sure that you're communicating with them, and then take a quick look at what may be involved with future code updates. So we're going to kind of do a high-level look. I mean, we could go in the weeds and just totally get lost in all the charts and everything, but I think the idea is that today you'll kind of get a touch on all sort of the outline of how the code's constructed, and hopefully it'll just plant seeds in your mind that you can know what to be looking for as you go into design. and then you're gonna have to delve in, you know, to all the particulars, but hopefully this will give you a good overview. So just quickly, kind of the history of how we got to where we're at with the energy code. The first code was, that I could find was the ASHRAE 90, 1975. Of course, that's evolved in ASHRAE 90.1. I'm sure you may have heard of that. The first ICC code, energy code, was in 98. And there were some model energy codes that they were kind of involved in before that, but IECC was first developed in 98, updated in 2000, and then it's been on the regular 3-year code update cycle since then. So let's look specifically at what we did here in Springfield, effective February 9th, so earlier this week. Our previous code, adopted ordinances said we were going to adhere to the 2012 Energy Code or approved engineering practices. The new adopted ordinance says that we're adhering to the 2012 Energy Code with an intent to adopt the 18 in 3 years. So they got rid of this approved engineering practices thing, and that exception allowed for some gray area to where the code was not consistently applied, maybe not enforced, plans weren't reviewed for it. So it's kind of been there, but hasn't really been enforced. And what's changed now is that they're expecting us to design and adhere to the 2012 Energy Code with some tweaks. Here's the actual ordinance verbiage here, and you see here that it says, the City Council declares the intent of the currently constituted council to adopt the 2018 or 21 in 2023, and again to solicit input from stakeholders at that time. So that's a snip right out of the adopted code of ordinance. So they really, even though it looks like we did 2012, it stayed in 2012, we've really raised the level of what's required here in Springfield with an eye towards, you know, taking another step and trying to align it with the codes that we're adopting in the future. So with that, they made some of the items non-mandatory, and these were part of conversations with the Springfield Contractors Association and you know all the stakeholders in the area. And the idea here is by making a couple of exceptions non-mandatory, we can kind of ease this transition to where we've maybe not really been designing to any energy code standard, and now when we're applying to 2012, maybe we can take out some of the real pinch points in adopting the new code. So here are the 4 items that they made non-mandatory. Lighting controls. I think a lot of the design we do today, we're using a lot of occupancy sensors, things like that. A lot of automated controls are just becoming more and more standard design practice. But the 2012 Energy Code does have some pretty detailed stuff, which we'll take a look at in a little bit. So those are non-mandatory, not required with the new adoption. Exterior lighting, and that has to do with lighting power densities. They've made that non-mandatory. System commissioning, and this is a big topic of conversation. We'll talk about when that would apply, but that's going to be non-mandatory with what we've adopted here in Springfield. And then building leakage testing unless required. So it's a little bit of a gray area in the adopted ordinance here. But the idea, and we bounce this off of Harlan and Kevin Pierce, kind of see if we're looking at this the right way. The idea is they're not wanting to require any building leakage testing on our commercial projects, but if they have an inspector that's going on site and sees holes in the air barrier and penetrations that aren't caulked, things like that, and those items aren't being rectified, then they don't want to waive this right to be able to go in there. Okay, you have to prove your building complies with the leakage rates that are prescribed in the code. So those are the exceptions. There's a couple other little things in there, but that's kind of the highlight. I guess one other thing I'll touch on. There's an exception for low energy buildings. So if you're using a certain amount of watts per square foot and below, you're exempt from certain requirements of the code, which is like if you got a garage or something that's not heated, you don't have to insulate and do all this. So there's a threshold there. And there was conversation that we raised that threshold a little bit here in Springfield to still qualify as a low energy building. So those are kind of the exceptions that we've adopted here in Springfield. So let's take kind of a look at the overall energy code structure. First of all, right off the bat, it breaks into commercial and residential. Today, the scope of my presentation is going to just focus on the commercial. The residential stuff is going to apply to 1 and 2 single-family dwellings. I got to look at this because they actually modified this with the adopted ordinance, but detached 1 and 2 family dwellings and multiple single-family dwellings, townhouses. So detached 1 and 2 family dwellings. So townhouses, detached, single family and duplexes, those would be classified as residential as far as Springfield is concerned. Everything else is going to need to comply with commercial. So here's kind of the structure of the code. This isn't like verbatim the chapters that are in it, but this is how I kind of see it as I look through it. It kind of breaks into these general chunks. There's some general requirements right off the top, envelope requirements, which you're all more experts on than I am, but we'll take a look at what the code's going to say in there. Mechanical equipment, service, water, heating, lighting, power, and then the verification piece, which is commissioning, that type of thing. So we're just going to kind of hit each of these and take a little look at what's in each one of these sections. Oh yeah, so another thing I think about, when I'm thinking about the envelope, I think, you open the code and there's a bunch of graphs and charts and sections and, you gotta overlap this and seal this and whatever. I think it really is breaking down to 2 overall goals with the building envelope. One is they want you to maintain continuity, and then they're prescribing a minimum performance of the materials. So insulation, R values, thicknesses, things like that, window shading coefficients, these type of things. And then the continuity piece is telling you to caulk joints and seal any joints. So the code's kind of, it can seem like a bit of a rabbit hole, but if you just think about these things, like everything that it's trying to do in here has these goals in mind. That's kind of my opinion on it. So it kind of, everything seems kind of logical when you think about this. So hopefully that helps kind of spark your thinking when you're thinking about designing your building. And on MEP systems, I see it breaking down to performance, so equipment efficiency, SEER ratings, lighting, wattages, things like that, and then demand adjustment. Can you turn it down? Can you turn the lights off when you're not in the room? Can you turn your fan down when you don't need that power? That's what the code's 2 main goals are on the MEP systems. So everything, as complicated as it seems, it kind of makes common sense when you start thinking about it in those terms. Okay, so let's jump into general requirements here. And so first thing it tells us is, gives us 3 compliance options with the energy code. Right off the bat, it says you're in compliant if you design to ASHRAE 90.1. I generally find that to probably be a little bit more restrictive than the energy code, than the IECC code. But it's an option that's there if there's something that may help your building out with your design. The prescriptive path is what we're probably most used to designing to, and that's kind of what we're going to talk about today. That's going through, just kind of filling out all the requirements. And then the performance path. The code dictates a baseline building, and through modeling and other methods there, you're proving a performance upgrade over that baseline building, and if you exceed it by a certain amount, then you can demonstrate compliance with the code. Similar to what you're used to doing on like a LEED project where you're modeling and kind of trying to exceed this baseline by a certain point. That may be necessary in some cases if your design is something that just doesn't fit into the mold of what the code is trying to dictate. The next thing we see in our general requirements are some design criteria. And first thing, it kind of dictates climate zones. We've got this map, and you can see they've kind of given a zone to all the different parts of the country. All Springfield here and all our kind of surrounding counties were climate zone 4A. The code makes a lot of exceptions for different parts of the country. Maybe way up north, they're not as picky about your cooling requirements. Maybe they don't require an economizer or what. Down in the dry areas, maybe you don't have some humidity requirements that quite the same. You don't have to meet all the humidity requirements. But in climate zone 4A, we get no exceptions. So we have the hardest area to design to here. So pretty much everywhere I read through, there are exceptions, but none of them apply to us here. So, and there's a chart in there where you can actually go look up each individual county and see what climate zone you're in. Another thing it dictates to us is thermostat set points that we have to use in our load calculations. So the code says that your minimum thermostat set point is 75 degrees and your maximum 72 degrees. That doesn't mean you can't set your thermostat to 72 in your building, but it's saying when we're doing our load calculations, this is what it expects us to design to, which is kind of interesting. Maybe a conversation that may change some design practices, but. And then kind of final thing in the general requirements, it has some just material requirements. So it's saying that materials have to be marked so that an inspector can go out on site and kind of see okay, this insulation complies with what's supposed to be here. And then it gives some rules about how materials are supposed to be rated. So that's the general requirements in the code. So now let's look at the envelope. I'm just curious, who's designed to the energy code, designed them, be it in a different municipality or whatever? Yeah. Okay. Yeah, I'm sure you guys are very familiar with all this stuff. So, but here's what they're dictating to us in the envelope. We've got your opaque assemblies, fenestration, and air leakage protection. That's kind of how it breaks down that envelope section. So looking first at opaque assemblies, you're probably, those of you that have designed this are used to this table here, where it's dictating to us based on your climate zone and your construction type, you have certain insulation requirements. So, for example, we're here in this column here, climate zone 4, and then this chart here is talking about your above grade walls. So, if Tanner was up here, you could. So this talking about these above grade walls. So, and it says here that like a metal frame wall, you come over here, you have to have R13 insulation and I think that's a 7.5 continuous insulation. So this kind of prescribes all the R values. You can see the roof R values and your floor R values, things like that. And then this table here, 402.1.2, gives it in terms of an assembly U value. So I think this is the intent here is that you can actually calculate the whole U value of your wall assembly or your roof assembly or whatever and prove compliance through this method. So this maybe gives you a little more flexibility if it can't just be a straight application of insulation values. So you can comply with either of those and you can show compliance for your opaque assemblies. So looking next at all your fenestration, there's a few requirements right off the bat. This is maybe may have an influence on your design. It's a constraint here. It says that your maximum vertical area can be no more than 30% of your wall. So they're dictating to you right off the bat there how many windows you can have in your building. So that could be something that kicks you right into a performance compliance method if your design can't adhere to this. This is an additive thing though, so it's not for every single wall. You can take the whole of your building, and as long as you meet that 30% for your entire building, then you get in compliance here. That also gives you a limit on skylight areas, but if you create some daylight zones inside the building, you can bump these up to 40%, I believe 5% for skylight areas. To do this, I've highlighted it here. You need to coordinate. This is a coordination point with your MEP because they may have some other lighting controls that are associated with those daylight zones that need to be taken into account. So that's a limitation there. There are minimum daylight zones that I kind of boil this down to large areas with tall ceilings. I mean, it spells out, you know, maybe mall atriums, these types of spaces, convention centers, things like that. So if you're thinking large areas, tall ceilings, if you have this kind of a situation in your design, dig in and see what it might require to you for a minimum amount of daylight zones. And then we've got another table, which this table is just spelling out our required U values, sensible heat gain coefficients, you know, that are required for all your windows and skylights, things like that, all your different fenestration. It allows for an adjustment. If you have a north-facing window or you have a certain overhang, it lets you bump the sensible heat gain, shading coefficient up. You can allow a little more heat through light in through your window. It's just kind of a common sense thing. If you have north-facing glass, they're not going to hold to quite the same standard because it's not going to see the sun. And then the final part of the envelope requirements is the air leakage protection. So it's kind of broken into several different sections here. And it talks about the construction of the envelope, penetration, leakage, doors and shafts, you can see all that. This is the continuity part of the conversation here. So just kind of looking at the requirements that go with each of these little items. Your air barrier needs to be continuous. All the joints need to be sealed. Penetrations need to be caulked. And here's a coordination point for your MEP engineer. Your recessed light fixtures need to be properly rated. So if you have a recessed light fixture penetrating your exterior envelope, it needs to be rated for insulation contact, IC rated, and it also needs to have a listing for a certain amount of air infiltration through the fixture. Now, what's interesting, to me, this only comes into play in a canopy where you actually have a recessed can light. A wall sconce, that's a surface mounted fixture. So you're more into your caulking, your penetration there. So, and I think even those, a lot of us are using those low profile LEDs that you install in a junction box. To me, that's a surface mounted fixture as well. And Harlan can agree with us on that too. So, but anyway, that's if you find yourself you're needing a can light or something your MEP needs to be looking at to make sure you're complying there. And then it talks about the materials that can be used for this air barrier. It just gives maximum leakage rate for the materials and then a maximum leakage rate for the entire assembly. So this fairly standard stuff. It does then talk a little bit about penetrations. This is fairly obvious, but there's another little section in the code. So it's saying to caulk, gasket, and seal all your penetrations in your air barrier. It prescribes through this table 402.4.3 maximum leakage through your fenestration. So you've got, your storefront glazing can only be 0.06 CFM per square foot. And a lot of that's going to be taken care of on the manufacturer side. So it's a matter of you're probably specifying these rates, and the manufacturers and the providers of the products are going to need to comply with it. Doors to shafts and chutes, they want you to gasket, doors and stairways, kind of anything that can have a chimney effect in the building and maybe move air through it. It does make an exception for fire doors because this gasketing could interfere with the fire door performance, and fire doors just inherently are probably going to be a little tighter than other doors. But they're just trying to, these type of spaces, elevator lobbies, stairways, chute shafts. If you've got an access door or a door that you can walk through, that has to be gasketed. Any air intakes to shaft vents, elevator shafts, things like that, they're required to be motorized dampers. And of course, this is just something that your MEP needs to be looking out for. You can't necessarily use gravity backdraft dampers. There's a CFM threshold, so this is if you're getting above a certain size, then that will be required. And then the city of Springfield has made an additional exception that you can take, there's some exceptions in the code for 3-story buildings that are 3 stories and lower where you can use gravity dampers, and if you more locations. And Springfield changed that and made it 4 stories and lower that you can use these gravity units. Anyway, motorized dampers, a thing to be thinking about. Your MEP needs to be looking out for that. But that's part of the air leakage protection in the envelope. Loading docks equipped with weather seals. This is fairly simple. And then vestibules are required in certain cases. I kind of distilled this down to these rules. So obviously you can kind of need to do your own study on a given project. Areas over 3,000 square feet, doors that are intended for public use, and there are exceptions in there. So the point is, a back employee door or something like that that's not intended to have a vestibule in there. But if you're opening into an area that's 3,000 square feet or greater, and it's intended for public use, then you're probably required to have a vestibule. So you need to dig into that section and study that a little bit. Okay. Any questions at this point on the envelope requirements? Keep plugging forward. So we're going to get real in depth now. Yeah, I'll just hit the highlights again. This is just so you guys have in your memory bank that these are things you need to be aware of, and yeah. So here's how I see the mechanical systems being broken up. First, there's general requirements again, then they prescribe efficiencies. They have specific requirements associated with the equipment, and then there are some requirements that you have to meet on the controls. So as far as general requirements go, they tell us how to run our load calculations. We have to run it in a method that complies with ASHRAE 183, and they don't want you to oversize the equipment. That's a big source of energy loss and can really hurt your efficiency and your performance of your systems. So swagging a safety factor on something is not, not acceptable according to the energy code here. So if you follow your load calculations through by this method, then you're going to be compliant with the code, and you should have a right size system that'll perform for what you're doing. Remember, they told us also the thermostat set points we have to plug in when we're doing that sizing. So then we get into the system efficiencies of the mechanical code, and we get more tables, and there are pages and pages of tables. So I've copied them all here so we can look through them all. I've got a couple, but here's your air cooler conditioner up at the top. I doubt you can read that number, but that's like your less than 5 ton units. 13 SEER is what it's saying the efficiency has to be. This table here has P-tax on it, so if you're doing a hotel or something with P-tax, then it's saying these have to be, meet a certain ER rating. And then this one here is boilers. So here's your gas-fired boilers. If you're above a certain BTU rating, then you have to hit, 80% efficiency or whatever it calls out here. A lot of this is handled on the manufacturer side, on the SEER ratings, on the air conditioners. We're seeing those pushed up and up and up as the requirements are raised and tightened on these manufacturers. So they're getting, easier to hit in some cases. And the fact that we've adopted the 2012 here rather than 2018 probably makes it even a little bit easier for us to hit some of those. So there are equipment efficiency minimums that we have to comply with. It also gives a method out there where we can do our own calculations if whatever we're designing is not listed in that table. The code also specifying fan horsepower maximum, so this is keeping us from putting a really big fan on and then a damper right in front of it to damper down the airflow. It's saying right size your system, right size your fan. Obviously you're gonna have adjustment, but they're kind of giving you a cap on how much horsepower you can use for a certain CFM and trying to push through a certain static pressure. So the additional requirements that the code spells out for the mechanical system are, I kind of see it, 2 things. They have energy saving features that are specified, and that's your heat wheels, your duct sealing insulation type requirements for piping insulation, economizers in certain applications, and the ability to turn down your ventilation air when it's not needed. So these are energy saving features that are required in the mechanical system. Economizers is a thing to be mindful of. In the 2012 code, it requires, does everyone know what an economizer is? The economizer is just a full-size louver so that your air conditioner can bring in 100% outside air to provide cooling for your building when the outside air conditions and the interior space conditions aren't right. So if we had this room full of people and we're hot and if the weather's like it is outside, it's cool outside, so and we got a call for air conditioning, we would just open that louver up and bring air conditioning into the space because it's free cooling, right? So it's great, great technology, really great if you have rooftop units because it's easy to integrate. As long as the contractors get it set up right, you don't bring just fresh air in all through the summertime because there are adjustments on these things and they need to be calibrated. But anyway, the 2012 Energy Code requires economizers for equipment that's 3 tons and up, 3 tons and up. So it's not really big, 3-ton furnace isn't a very big furnace. So it's interesting because in the 2015 code, they moved that threshold to 5 tons, which is more of your kind of typical, maximum furnace size. So the idea was they kind of moved it to where if you're just designing split systems, you're not really required to have an economizer. So that may be something that's addressed before we go to the new code adoption in Springfield. But right now, as it reads, 3 tons and up, you have to have an economizer. So you'll have to give us MEP engineers some space for a louver, because now that's 1,200 CFM we got to bring in through the wall or the ceiling or something like that. Okay. And then, so there's energy saving features as far as our additional requirements. The other thing is they don't let you waste energy. So it pretty much boils down to these simple things. Don't run a heat pump at the same time as your electric heat. They want you to lock that system out. If you're doing outdoor heating applications, you need to be using radiant heat. You can't just blow air outside. 2012 doesn't have too many requirements associated with that. So that's pretty obvious. And then there's some requirements associated with the controls. And really, most of your standard thermostats have this stuff built in nowadays anyway, but you have to be able to set it back. You have to use programmable thermostats that you can set back when the building's not in use. There's an overlap restriction, so you can't set the thermostat at 72 and the unit will heat and then cool and then heat and then cool. Switch over and hunt all day. Has to be I think it's 5-degree separation between those set points, so that it doesn't fight itself. If you have a water system, be it heat pumps or hot chilled water system, if you have like a high heating demand, for example, the energy code wants you to be able to reset your temperature, your hot water system up, because everything's going to be more efficient if it has hotter water. You're trying to heat your building, you raise that water loop temperature, everything's going to be able to perform more efficiently. Less equipment runs around those types of things. And then fan speed controls to be able to turn down fans and adjust those based on demand. Now I'll take a quick look at the water heating, and it has a handful of different requirements. I went too far. No, I didn't. Yeah, okay. So here's how the water heating system's broken up. Again, it's another chart with our efficiency requirements, and then it has some of these other specific items that we have to think about while we're designing. Here's that chart I talked about. So you can see here, electric water heaters, certain kW cut off, and it gives an energy factor rating that's required for that equipment. So anyway, there's a couple of charts in there associated with that. Heat traps are devices just to keep hot water from migrating, or the heat from migrating out of the water heater up into the piping system. So these are just a standard fitting. You can do it with a piping loop, but we usually just specify a little fitting that goes on the water heater. Some water heaters even have it built in, but that's a requirement of the energy code. You're required to insulate your hot water system, your hot water piping. So above a certain water temperature, it requires a minimum thickness of insulation. And then recirculation control means you can't just let your recirc pump operate all the time. You need to be able to shut it off based on loop temperature or time, a timer or something to say the building's not occupied. In the 2018, it goes a little bit farther with what's required there, saying that you can't even run the pump. It needs an occupancy, a flow detection or some sort of occupancy detection, or else the pump can't even run. So And then there's some requirements about like the covers for pools and spas and how those rooms are sealed up and things like that. So that's what it has in there for us for surface water heating. Any questions after mechanical and surface water heating? All right, well, let's hit lighting and power. So, and as I mentioned, the city of Springfield has made exceptions to a couple things. So the lighting and power requirements kind of break out to these three sections, and the city of Springfield has made exceptions to those couple items. But we'll look at them anyway, so you know what's in there, and when these exceptions go away, we know what we're dealing with. So the first thing is lighting controls, and here's what's required in association with lighting controls. You've got light reduction controls are required. You're required to have occupancy sensors in some cases. Daylight zones need to be controlled separately. There's some specific applications that the code talks about, and then controls required for exterior lighting. So we'll just kind of look at what's involved with each of these. The first thing the code tells you is in certain scenarios you have to be able to reduce the lighting level, and it has to be able to be reduced in a uniform way to a 50% output. So it could be just dimming all the fixtures, which is probably the method that we're going to use with the advent of LEDs and pretty cheap dimmable controls. But you could also like switch alternating fixtures. You know, if you had a kind of a big area, that would be acceptable too. And then there's some exceptions for it. So if you have an occupancy, the occupancy sensor, you don't have to necessarily have this dimming control. If you're low power density, you can take that exception. There's some other spaces like corridors, some storage areas, things like that, where they don't require this kind of common sense stuff. You don't have to dim the lights in a janitor's closet. Occupancy sensors are required in these types of spaces. Rooms less than 300 square feet, is going to capture a lot of small rooms, but I'm sure you're used to putting occupancy sensors in many of these types of spaces. So, like I said, this is not mandatory right now in Springfield. So, if you still get the owner who insists that they don't want an aux sensor, then you can still leave them with the manual control. But this is just becoming kind of standard design practice in a lot of cases. And a thing to note is where you have these occupancy sensors applied, you have to have an on operation. So you have to go in and push the button to turn the lights on. Or if it automatically turns on, they can only turn on to 50%. And then you push the button and they come all the way up to full brightness. So they're just trying to eliminate just unnecessary turning on of light fixtures as much as the automatic turn off. So that, I think occupancy sensors are a net win, right? But we probably end up turning our lights on in some cases when we might not have. So they're just saying now that you have to go, actually, if you're going to put an aux sensor in, you have to go push the button and make the lights come on. Daylight controls. This is the thing in 2012 that could get a little hairy, kind of add a lot, add some complexity to the control system. That is pretty much the main reason that they kind of made the lighting controls non-mandatory. But any area, any lights that are in a daylight zone have to have a separate control. And here's the definition of daylight zone. There's an area under the skylights, just pretty much there. Any area just under the skylight, and then any area that's adjacent to a window, right, for fenestration. So pretty much the top of the window, you draw an angle down, and then 2 feet past the edge of the window, that would be a daylight zone. So if you had a fixture in that zone, 2 fixtures in that zone, they have to have their own control. See that, right? Sorry, Brian. But there's a couple exceptions. So this would be like an office, right? 2 or fewer fixtures. You don't have to have a separate daylight control for that. And then it also says this can be a manual or automatic controls. A lot of times automatic is probably the easier way to do it. You put a photocell in that area, and then you wire it to those fixtures, and then it just dim down based on the input from that photo cell, but it also could just be a dimmer switch on the wall. The code's just trying to make it to where the users are able to turn off lights that just aren't necessary. It's that demand control piece that we talked about. So then it makes some provisions for specific applications. If you got accent and display case lighting, you have to have separate control for that. You can't just control it with the overall room. You need to have a master control for hotel room suites. Task lighting needs to have its own control, and then it has a line in there for any grow lights have to be on their control too. So I guess the code's expecting a big boon in grow light usage. Exterior lighting controls need to be photosensitive or controlled with an astronomical time switch. So this is just saying if you're turning your lights on at night, you can't just have a dumb time switch that doesn't know the changing of the sun. It needs to be astronomical, so it adjusts that on-off cycle with the dawn and dusk, the changes in dawn to dusk. Or you can control it with photocell. So, and then the code says if you lose power, it has to be equipped with memory that'll save your scheduling when power goes out. In the future, versions of the code, you get into some of the dimming requirements that you'll see more of, where parking lot lights maybe have to dim if they don't sense anybody there. But those are coming more in 2015, 2018 code cycle, so more totally in play in 2012. These power density tables are something that we have to comply with, so this is interior lighting power. This is something we're complying with here in Springfield. There's two methods to calculate it. Either you can look at your building as a whole, you can find your office building and add up all the square footage and all the wattage, and if you come into 0.9 watts per square foot, you're good to go. Or you can do an interior method where you kind of look at each individual space, add up those square footages, look at all the allowances. If you meet them, you're good to go. We found these to not be that hard to meet, to be honest. I mean, it's especially the 2012 values. I mean, they've kind of a little more aggressive in more recent code updates, but with the way that LED lights perform, this generally isn't an issue unless you're really doing something crazy. So now this is let's see. Yeah, this is not mandatory in Springfield. Exterior lighting is regulated as well. The code has this lighting zone chart that kind of breaks your building area into a couple different categories. And then, so you can see, there's developed national parks here, rural areas, all the way down to high activity commercial districts. And based on those categories, it gives you a certain amount of wattage you're allowed to light your side of your building, those type of things. So this isn't mandatory. Again, right now it's not mandatory in Springfield, but again, these aren't too tough to necessarily meet in a lot of cases. Okay, so we've kind of gone through the requirements of the energy code. So our bottom line here is the verification piece. There's three parts associated with the verification. First is the commissioning. The codes are going to require commissioning, then testing and balancing, and then providing O&M manuals to the owner. So testing and balancing, something we've done forever, getting our own O&M manuals. This is standard practice. The commissioning is kind of the new piece. And 2012 was the first time that it made an appearance in the code. So let's look at what's involved with commissioning. This is what the energy code says you have to do. First off, commissioning applies to HVAC systems and service water heating systems per the energy code. It's not uncommon for a commissioning agent to commission the lighting control systems, but that's not required in the scope of the energy code. But for what the energy code says you have to do, you have to have a commissioning plan, functional performance testing. So after the systems are in there, you're going in, you're taking temperatures, you're making sure that the unit's heating when it's calling for heating, it's cooling when it's calling for cooling. A hot water recirc pump is shutting off when it's supposed to shut off, these type of things. Then you prepare a preliminary commissioning report. Then the code requires acceptance of the report. says buildings or a portion thereof shall not pass the final mechanical inspection until such times as the code official has received a letter of transmittal from the building owner acknowledging that the building owner has received a preliminary commissioning report. So until you've done functional performance testing and got your report submitted to the owner, you can't get your final mechanical. So if you think about how that could impact the closeout of the project, and maybe, I know a lot of times we're trying to do punch lists where when mechanical systems may not even be online yet. So commissioning, there are ways from maybe even being started up in some cases if the project's really crunch for time, much less commissioned. So now there's going to be deficiencies in here, and those don't all have to be fixed necessarily. And so, but the preliminary has to be done and submitted. Then you go back and you do a final commissioning report. That's not holding up completion of your building, but the commissioning agent does need to go back, make sure all the deficiencies have been corrected off that first report, and prepare a final commissioning report, give it to the owner. I think the code says it has to be available for their review, but it doesn't require transmittal to the AHJ. There's a BTU cutoff. I don't remember the BTUs, but it translates to roughly a 16,000 square foot building. So that and below, this isn't required. Commissioning is not required by the energy code. So that's something to keep in mind also. This isn't every 2,000 square foot infill, doesn't have to be commissioned. But anyway, and as we talked about before, this is all non-mandatory right now in Springfield. And you can see why they did it. I mean, it would have been, anything that you're getting ready to send in for permit, if it's not in already, it would have had to meet this requirement. So it's something that could come in the future, may come in the future. It's a great value to a project, honestly. I mean, I think the owner benefits from commissioning a lot, but it's not required right now by the city of Springfield. So anyway, that's something to have in mind. And then, like I mentioned, test and balancing, O&M manuals. These are things that are kind of standard practice we're used to doing. Sometimes we get contractors that try to BE out the test and balancing, so we can't let them do that anymore. Thank goodness. And then, get our owners to O&M manuals. So that's kind of the summary of what's in there. But let's talk about what to put on your construction documents that go, that show that you're complying with this. It's got this section in here, C103.2, which lists all these things that the construction documents are supposed to include. U factors, sensible heat gain coefficients, R values, equipment efficiencies, sizes. A lot of that stuff's probably on there already because we're specifying it. But one of the best methods that I see to show compliance with the energy code is ComCheck. And is anybody familiar with ComCheck? All of you that design energy code stuff. So ComCheck's a great piece of software to use. It's a free software that the Department of Energy puts together. And it'll spit out a compliance report. So you put your project information into the ComCheck, and it'll come out and actually say, that you've passed. And it serves as a good checklist for compliance. Let me show you an example of what one looks like. Any of you that have done this have seen it, but even if you have, you may recognize this. But here's a project, we put our overall square footage in. These are different light fixture types and quantities. Our wattage met it, so we got that our interior lighting passes. Here's a mechanical one. So this just has a list of all the mechanical equipment. And ComCheck also spit out this document here, which it serves as an inspection checklist. So, I can read what this says, but it'll say things like, units are equipped with economizers for 3 tons and above. And it says, complies, does not comply, not observable, not applicable. So, with this checklist, I really like to, as soon as you know what's going on in your project, as soon as you can have an idea of what materials you're using, for us, equipment sizes, things like that, equipment types, I would do a little sketch like ComCheck, because it gives you that checklist, and it's really handy to just read through that before you get too far down, because it's nothing worse than you're done with your design, you pull that checklist out, it's like, ah, darn it, I gotta squeeze it out of the economizer, and I gotta call Jason up and get a louver in my wall, and he's gonna be mad at me, you know, whatever. So I think getting that out early, and you're gonna have to go back and put your final information in there, refine it. But anyway, that's just my opinion. But I think the comp check can serve as a good checklist for compliance, and it's helpful to do up front. There's a lighting comp check, mechanical equipment comp check, and an envelope comp check. So the envelope comp check would be what you all are putting on architectural plans to show compliance on your sheets. Your MEP should do the lighting and mechanical, unless you want to do it. And then we like to stick them on our drawings. I mean, I think you can turn it in with a spec book, or here in Springfield upload it as a separate report. But if we're thinking about it ahead of time, we'll try to get them on just stick a PDF on one of our sheets, so it's just on a sheet in our drawing set. It shows the plan reviewers that we've thought about the energy code, we've complied with it and whatnot. One thing to note is obviously there are some exceptions in Springfield, right? We've got these non-mandatory items. So depending on what you put in, you may not get the green pass bar on there. So I don't really know the best way to navigate that yet. I think we'll probably as a design community kind of figure out how we go about that. I would probably tend to put something off to the side in a general note that says kind of the exceptions, maybe where our design differs from what's in here. So we've got a green bar, but maybe we don't have daylighting controls or something like that. Or check that's not applicable. This is what I'm planning to do is check that's not applicable box on those type of things, and hopefully still get the green check in the comp check. So that's a good way to, this is a good tool to have in your CDs. I think that the city is looking for something like this to show compliance, and anybody that's designed in a municipality that requires energy code knows that you have to turn these in. So the final thing I want to look at today is what updates we could expect with the 2018 code or the 2021 code when they go to update in 23. So 3 years from now. That's the goal anyway. But here's some of the things that are going to be in there. All those charts we looked at, I think we can expect the R values to go up. I mean, we know that they have gone up already from the 2012 to 2018, but those, R values are going to get more aggressive. Our equipment efficiencies are going to go, they're going to have to be more efficient, or, wattage is going to have to go down. The lighting power densities are going to have to go down. One of the big things in HVAC is there's requirements for variable speed fans and multi-stage compressors. So it's just ability of units to turn down in their operation. When they're not at full load, they can turn off a stage or modulate down. It's going to be great for conditioning, but it's more costly equipment. Automatic receptacle shutoff. This is something that's in ASHRAE 90.1 now. It's not in the IECC yet, but it says that in certain spaces like offices, 50% of the receptacles need to be controlled based on occupancy sensors. So they just have to shut off. That's something that could be coming that we need to be aware of in future code updates. Then this hot water recirculation limitations, the 2018 code, I think it starts in 2015, specifies that your recirc line for public laboratories, certain size piping, it can't terminate any farther than 2 feet away from your faucet. So just in practical terms, what that means is if we had like a bathroom group coming out here, we couldn't stop our recirc line out in the hallway. We have to bring it all the way in the wall, down to the faucet, at each faucet. So it's just, this extra piping. You get the point is that people don't sit there and run water all day and probably get hot water right to here and then walk away because they can never get hot water or whatever. So you understand the logic there, but it's something that'll impact our design in the future. So those are just kind of updated things. Obviously, if they removed any of these non-mandatory items that we talked about today, what's in there, but and so you kind of have an idea now of what type of impact that could have on your project. So So that's all I have for you today. I'd be happy to take any questions. Come up with any in the last sector of the program.
So Brad, I mean, occupancy sensors are so ubiquitous. Why did the city elect not to make that mandate?
I think I don't really want to speak for them too much, but I think it mostly had to do with some of the daylight controls and some of the mandatory dimming and some of that stuff that could, in certain cases, potentially kick you into a more complex control system. And it just kind of, rather than getting in and trying to cherry pick sections here and there, they just kind of took that whole set and made it non-mandatory. So that's that. I don't, like I said, don't want to speak for them, but that's kind of my perception. Yeah.
I'm curious, what's the process of how they adopt this code and the exceptions? Is there a team there that's very knowledgeable about energy code? And
It was kind of a impromptu, a simple group of people that just sort of weighed in and they sent to AIA, ASHRAE, the codes were out there for comment, the draft ordinances were out there for comment. I think the city did a good job. They spent a lot of time going back and forth with the contractors. The residential code was a challenge for them too, working with the HBA. But they spent a lot of time just kind of trying to get input and putting their drafts out there, and I'm sure it's in all of our emails somewhere, throughout the deal. But yeah, they really tried to seek out some input from stakeholders. So.
Did you guys happen to talk about how it will be applied to level 2 and level 3 alterations in the existing building?
That's a good question. I mean, generally, the energy code actually has some verbiage in there that is talks about existing buildings, and I think if you're doing a significant, if you're remodeling an area of a building, you need to be thinking that it's probably compliant. You probably need to be compliant with the energy code. If you're adding onto a building, that addition probably needs to be compliant with the energy code. Specific cases, you probably need to seek a ruling. If you think that you're lightly touching something, maybe I would seek a ruling from the city and make sure you know how they're going to interpret it. But generally, I mean, if you're going out and replacing light fixtures or HVAC equipment or building a new wall or something, I think the intent is for that to comply here. But the IACC actually has some verbiage that kind of describes what's required in that case. So. Well, thanks everybody. Great to get to talk to you.
Sorry about the clicker.
Thank you so much, Brad. He's just, you're a really valuable part of our board, and we really appreciate it. So, talk to Brad afterwards, and also, and I know there's other supply here, any other allied members here? So, just say hi to somebody on the way out. Remember to click on the AIA link if we don't want to do classical architecture or all of the buildings. And I also have some calendars up here, just extra calendars, so if you're interested, it's still February, so it's useful for the next 10.5 months. So, thank you.
I'm sure this thing isn't actually busted.
There's no.
Just leave a check for that.
Yeah.
You guys can just donate to the school.
Okay, I will. I can't believe it.
I think those batteries were weak.
Yeah, they were a little bit.
Yeah, just jostling.
Wow, that's what I wondered.
It's about a $5 piece of equipment. So
I don't know, Brian.